Welcome to Mogbe Academy, where we simplify complex engineering topics for students like you. In this first series on heat transfer, we'll explore how energy moves in the form of heat, through solids, liquids, gases, and even through space. Whether you're studying mechanical engineering, thermodynamics, or preparing for an exam, this lesson is for you. By the end of this lesson, you'll be able to define heat transfer and explain how it works. Understand how it differs from thermodynamics. Identify the three main modes: conduction, convection, and radiation. Apply formulas used to calculate heat transfer. Recognize examples of each mode in everyday life. Heat transfer is the study of how thermal energy moves between two systems, specifically due to a difference in temperature. Heat always flows from the hotter object to the colder one until both reach thermal equilibrium. And it can happen in different ways, through solids, fluids, or even without any material in between. Now here's the key difference. Thermodynamics tells us how much energy is transferred. Heat transfer tells us how fast it happens and how it travels. So if thermodynamics answers how much, heat transfer answers how fast and how. Conduction occurs when heat is transferred through a solid material, without any movement of the material itself. It relies on atomic vibrations in non-metals, free electron movement in metals. The formula used to calculate conduction is Fourier's law, where Q is heat flux, K is thermal conductivity, dt dx is the temperature gradient. Example: a metal spoon placed in a hot bowl of soup becomes hot from end to end. This is conduction through the solid spoon. Convection is heat transfer between a solid surface and a moving fluid, like air or water. It happens in two ways: natural convection, caused by fluid movement due to density changes, like hot air rising; forced convection, caused by external sources like fans or pumps. This mode follows Newton's law of cooling, where H is the convection coefficient, A is the surface area T's, and T are the temperatures of the surface and fluid, respectively. Example: when water boils, hot fluid rises and cold fluid sinks. Radiation is the transfer of heat through electromagnetic waves. Unlike conduction and convection, it doesn't require any medium. It works even in a vacuum. The hotter the object, the more radiant energy it emits. This follows the Stefan-Boltzmann law, where E is emissivity, 0 to 1. S is the Stefan-Boltzmann constant. T's and SUR are surface and surrounding temperatures. Example: feeling the warmth of the sun on your skin. That's radiant heat traveling through space. Thanks for watching Mogbe Academy. If this video helped you understand heat transfer, please give it a like, share it with your classmates, and subscribe for more breakdowns like this. The full lecture note is in the description below, ready to download. Drop a comment if you want us to explain Pascal's law, Bernoulli's principle, or any other thermal topic.